live? Ah, okay, mic was muted. I had... Hello guys. I had to go down to HD resolution today for ultra low latency, since we want to interact in real time today. So I just scaled down. OBS is still sweating with 4K, but has to scale down for YouTube for HD. Oh wow, hi. We have all the Davids, all the Peters, all the Robs, Greens, Mats, JTags, Rays, Mikes, Warden, Embedded Hobbyist, Andy, oh wow, and Sion is also there. Okay, so this is my ultra old camera because my GH5 is here and the G9 didn't arrive yet. And I can maybe, I can break it, my setup. Okay, so this is like a really strange, okay, this is a microscope. I hope it doesn't tip over. This is the adapter for the microscope. It's the 1x lens, which isn't very good, but with the Micro Four Thirds sensor, can I detach it? That's like a converter from this, what is it, C or L mount? No, I'm not sure how this CCD camera mount is, but it's way smaller, and this is a small plate that I am able to screw on, and now I am able to use my GH5 also with the microscope, and I'm doing that only for the bigger field of view because I'm waiting for the other adapter that Johnny has recommended. And that looks like that. Okay. Oh yeah, is it? Oh, it's zoomed. Look at this. It's already zoomed in, and I have another lens that I didn't had last time. Maybe I can show this as well. Yo. Here. So there is another attachment here on the microscope. I paid way too much for this small lens here. This is 0.5 adapter lens that simply improves the distance between the microscope and the table. So I'm able to work there as well. Are you from Germany or Austria? I am from Germany. Okay, let me read the chat. You guys have some stuff to say or ask or whatever. Ah, okay. Oh. Was the sound on? Yeah, microscope has the sound. I tried to optimize my settings a little bit earlier. While Sion stream was running. Butter, yeah, but butter is important. Smooth HD. You need to get Dustin Watts' YouTube roll call app. What is the roll call app? Cable tie. Yeah, I missed you too, guys. Long time no see. Yeah. There's okay. Maybe that was too delayed with the. There's nothing wrong with the camera. It's still here. Now I can even show. Oh, maybe I can show it under the microscope. Ooh, we can take a look at the sensor. Nothing wrong, but the field of view, because the sensor of the GH5 is micro four thirds and the CCD camera has like a smaller sensor. I need another adapter tube here between the microscope and the camera, because the view was so narrow you wouldn't be able to see like the ESP module or anything. So that was the issue. I'm waiting for an adapter. Oh, this is. Oh, we want to see the chat. Sorry, here is the chat, and let's. This is. This is the CCD chip. Okay, you are probably seeing a potato quality in HD. Okay, and if we zoom in further, oh, I need to increase the, and can we see some pixels? So the light isn't strong enough if I zoom completely in. So, sorry guys. I hope you don't get dizzy. These are the bond wires of the image sensor. Yeah, it's maybe I use no higher ISO setting. Yeah, but then we get like a really grainy quality, and we see there are some dust particles on the adapter here. I couldn't get them out. Yeah. But I need to put it away before I get some dust on the sensor there. You don't want to see in my future videos dust in the image all the time. Okay, let's zoom out again. Oh no, there is already something on the sensor. No! How do I get this off? There's a particle there. I need to take a hair. Maybe I take a hair and use my hair to remove this particle there. This is there is a particle. No, this is not the one. I'm looking for that one. Oh, that's mirrored. Is this mirrored? Yeah, it looks like. Yeah. Okay, this is silly. Let's stop it. You got the point. Okay. What we actually want to do today, we'll get this camera away here. What we want to do is I want to build these things here. I still have eight boards. I have 4 PCBs, so it's 10 in total. One I given away to Aaron, since he helped me with the USB host IC, and I want to, since I still have them and I have all the components here, and for so many components, this is the BOM file. It's way too much setup to just place another 8 boards, because this board will never be released like that. I will probably switch to the C3, ESP32C3, to make this a product, if I ever do. Oh, now it's completely blown out here. So, and if you stream long enough, can you pass back to unexpected maker? Yes, like we could. What we building? Okay, yeah. Hello, Photochromax. Oh wow. Okay. Compressed air. Yeah. I bought a compressor. I can use a compressor for that. I need to get it down here, or I need to get some canned air. Totally forgot to order some. Oh, you know what? If you missed the stream on the main channel, there was another file like that looked really big on this USB stick, and I printed it today, and it was to just use up the remaining resin. And it was like only not even an hour, but the build plate is completely full of stuff to benchmark stuff. So maybe I can show it as well, because it really prints down to the pixel, to the voxel. So maybe I can show it as well before we start assembling the stuff. So, okay, so this complete build plate, it was under an hour. It really, okay, this is a potato webcam. I can switch to the microscope again, maybe we can take a look at this. M2, no, not the screws again, but oh. Okay, let me show it on the face camera first. This one has at least HD quality. So they're like hair thin thingies on that plate. Oops, tries to focus my face. So this is like a benchmark. And the build plate is full of that, because it doesn't matter if you print one of them or all of them at once, it's the same print time. Okay, microscope. I can see I can see anything here. Oh wow, if you only could see this in 4K. Here, I want to show the thin stuff. So there you can see the limits. It's like only a few voxel, yet it's still attached. Okay, for comparison, I will show an 0603 SMD or something. Do I have one here? I have some SMDs here. Where's the camera? Oh. Where did I focus here? I'm not even sure where I am. Where's the camera? Okay. Am I too high or too low? I'm too low. Oh yeah, here. So this is an 0603 component in comparison. Look, it's even flexible. Okay, I didn't cure it yet. Oh, we have a delay. We have a delay. You have a delay. Trolling you. Okay, how I'm not able to maybe fix that delay right now. Sorry. Okay, so I think you have. Oh, how poisonous! Can I show more of this thing? There I feel. Okay, I not sure if I will be able to focus. Oh, okay. Oh no, it doesn't go further up. I won't be able to focus on that. Okay, maybe there. There are some holes. Oh, I love this microscope already. I will be showing off all this, all the fine details from this print, or whatever we decide on to print on. Let me bring this back. Okay. Quality is impressive. Hairbrush. Okay, so I forgot how to make a stuff. Here, potato quality again. Let's turn this down a bit. I found this stencil. This board was made a year ago, so I'm really like not sure how that works anymore. So I'm not. When did I use the last time? When did I post anything about PCBs the last time? I think this is the right way around. I will be doing two at once. And well, it seems to align properly. I have this cool paste that Sion recommended to me. That was Chip Quick. That the paste that stays good in room temperature. I hope it's still good. Oh, it's a little bit more viscous than last time. Oh shit. Oh no. And yeah, you probably are not supposed to like keep it for ages. Okay, let's see. Let's see how bad it is. No, it's fine. Okay. Oh, yeah, no, it's really thick. I will rub it off the bigger pads, maybe. Okay, let's check. Yeah, you are not able to. Oh no, that doesn't work. So it doesn't, like, the really fine pins don't work with this thick paste. Damn, I need another paste maybe. It still might work though. I will show on the microscope what I got now. If I turn on the lights. Oh no, the light was just dimmed. This is what I meant with field of view, and now imagine the field of view without, like, with the smaller sensor is even tinier. But let me show the issue. Okay, this looks fine. What the problem will be? Not where am I? Is this? No. I think this is mirrored. Yeah. No, it's not mirrored. There. Look at this. Okay, I have a little bit more paste now. It will reflow, but I will have some bridges probably. It's too much paste. But other than that, I'm quite satisfied. What do you think? Let's take a look at some soda balls. I put away the remaining paste. Good night, James. Turn 90 degrees. Wait. No, it's right. No, it's really like 180 degrees. But how? The camera is like rotated this way around. If I rotate a different way around, then I already set the cables up. Let's leave it like that. You will look from the other side here. Okay, let's zoom in and see some solder balls. Shall we? Focus. Look at this. I hope you can see this on HD. So this is 0.5 millimeter pin pitch. Scrape it off, put on once. Yeah, but the first time there wasn't enough. There were pads that had no paste at all. Yeah, we will just rework the bigger ICs. This should work. Let's not waste any. Oh no! I slided it beneath. No, it's still okay. I thought I have smeared the paste. Okay, it still should work. Okay, I have all the components here. Let me zoom out again. All the components here, but okay, this is better. Not sure about the order here. Okay, let's start. Start with my list. 1K. What? I'm not sure if I... Oh, did I prepare the 1K with the first one in a row? Where is it? Oh, there it is. Okay, 1K resistors. So this is R5. R5 is over here. You can see it already. There is R5. Is the R5 here? There. Okay. Spray can hold solder paste. That would be cool. Okay, the first one check. 10K now. That's the 10K. How many of these? I can only see 2. And that's R25. Where is 25? There. That's the USB circuit. The one before I started using the other CH IC for that. Okay, that's all. Just add a lot of flux. Then we need 4.7K. That was here, yeah. I have this on a spool. How many? Also 2. And this is R33. That should be here. Oh no, it's flipped. Wow. It's like, come on. It doesn't want to flip. It's upside down. Okay. Hope it still reflows here. Oh, you can see it here. Oh, you can still read the label. That's nice. I can barely read it with my... Oh, wait a second. Why am I not using the microscope? Oh, wow. Oh, that's much better. Cool. Nice. Okay, yeah, I should use the mic. Oh, okay. Oh, R2. R2 is 300 ohms. That should be 300 ohms. Is this one here? We need quite a few of these. This is the resistor ladder here. Let's make it fit on screen here. Okay, we have a shift compared to... Okay, this should be okay. That's really boring, you guys. You can sleep now. I won't surprise you. Maybe laugh out loud from time to time, but it's like a sleeping pill. Watching me putting on some... Oh, I can see the resistors. How can I... No, that's not convenient. That's the rotation. Need to rotate it this way around. Ta-da! I also dislike this tweezers here. Oh no, that one is different way around. Okay, it's not in focus for you. Like that. It's everything. I think the lens, this adapter lens. Oh, that's much better. It's like a different focal point on the outer edges than the center. The tweezers are too wide. I need another pair of tweezers here. Set your chair higher. Okay, I might. No? I need like really fine tweezers here. That are too wide. Oh yeah, these are really light. My chair higher. Should I get a nerd neck? That's what you want? Oh. Oh. Oh, baby. Oh, the tweezers are much better. They have like the force to is way lower to close them. Oh no, which is upside. Okay, got the right 50% here. It's interesting. That's center it a bit. If the solder paste wasn't dry enough, it will take some time until we placed all the components. And here is the next one. Pattern is broken. Human beings always looking for this safety, the false safety of patterns. Embrace the chaos. I should put the resistor upside down. Oh shit. Yeah, that will flip when we reflow it. The one bet. Oh wow. I'm not sure if I'm getting wasteful, but the care for individual SMD resistors is less and less with each year that I'm doing this. I pulled this spool from the pick and place machine and simply didn't care if there was like 20 or 30 SMD resistors in the front that would fall off or anything. It's really not worth trying to save 2 cents or something. I'm spoiled. Okay, this is the resistor ladder. Bye, Paul. Oh yeah, there like, is there a pattern? 2, oh no, that it's an encoded message. It's encoding with that's encoded how many, 9 so 8 bits plus parity, and it's encoding B for bitluni. Oh, okay, I think this was 2R, now 150 ohms. While we are at the resistor ladder here. We need only 6 of these. Oh. Oh. I hate resistors with the codes on. I really like when you can, when the value is human readable. I'm always like wondering how the people can remember the color codes of through hole resistors. Not that I'm not even able to see the colors properly. And then on top, remembering them, it's even harder. It's much nicer to work like that with the microscope in such. Can I set the sharpness higher for you guys? Because my eyes will adjust. Oh yeah. Enhance. That's like super fog. Ooh. It got worse for me though. I will adjust it and not at the eyepieces here. Oh yeah. That is 150 ohms. Hello, Yumbo Prime. Which board is this? This is this one here. So this is like rover module with SD cards, 2 USB hosts, VGA ports, and audio jack, and it's like a DOS emulator board that I started to do like a year ago. Promised everything and never delivered, as always. Yeah. There is so much stuff happening right now with the ESP32 library. There is Martin who have posted like pull requests just from the beginning with all this VGA stuff and the composite stuff. And he's actually a medical doctor, and but he likes to tinker around, and he started to play around with this composite stuff and with VGA, and he simply committed or some pull requests with improvements of the library, and I gave him the complete rights to do whatever he likes with the library, because the stuff that he does is so magnificent. He managed to add, that's in beta right now, add NTSC color, PAL color, with the resistor ladder, with which I wasn't able to do properly. I don't know, he said it was a mismatch in frequency. And he also implemented VGA, 1-bit VGA for ESP8266, and PAL and NTSC also for ESP8266. So really crazy. Not everything works with Wi-Fi, but still he did quite a lot of work. Also with audio, he consolidated the audio libraries, and I hope that this will be like published in a new release of the library, or I will rename the library, because it's not only for ESP32, it is also for the 8266. Yeah. Okay, T82. 82. Where's 82? I had 82 here. Oh! I think I prepared 82 here. This is 82. So this is the trim resistor. Only output. Sorry, there is no... okay, it might be possible to somehow get like black and white signal. Somehow over I squared S into the ESP32, but yeah, I'm not sure. The analog the analog ADC is like really bad. That wouldn't work. It is even not recommended to use for audio. What's unfortunate with this new ESP32C3, I checked the draft, the technical documentation draft, that there is only one I squared S channel. So you won't be able to use a camera and output at the same time. It's a little bit messy, but it should work. So this was component number 6 of 28. But the other ones are much easier. Where is this? Oh, switch. Oh, what is all that here? Okay, these seem to be like bigger ones. Let's continue with the passives. All the capacitors. Okay. Here, that should be 100 nanofarad. Yeah, I don't know with this regulation stuff. I'm only using here the rover modules with CE on them. So I'm not as much worried as Xeon is. Also because it's like I don't sell like huge quantities. It's only like hobby level. Oh, good night, Johnny. CE Chinese export, yes. I think the Chinese export CE is narrow. Oh, or is it wide? I think it was, okay, C7, C8. Oh, we need quite a lot of these here. I will just pull out some more. Oh. C7, 6, 7, 8, and 11. It should be here. No. Oh, 6 and 11 are outputs for the USB. Okay, let's 7. Okay, yeah, that's the circuit. That's the complete circuit of the host stuff here. Let's start with that one here. C6. It's really blocky. C7. The microscope might be also tilted a little bit. That's why the sharpness could vary. C8. No. Yes, C7, C8, C6 and C11. 11 is over here. And the same over there. Most of my boards are sold to UK and US and Australia, and since the UK is leaving soon, not sure if I need CE there. But let's not start about politics. I heard that that if there was a vote, Brexit vote now, it wouldn't be successful. But still scary stuff. Okay. Okay, that was that one. Then we have C1, 2, and 3. C1, 2, and 3. So this must be here. C2, C1. Okay, I can see every single one of them. How many boards are you selling, Quindor? Or shall I say Quinn? Okay, before I rotate it, I do it over here as well. Oh, it was off screen. I'm sorry. Is there a reason? Yeah, I said I have only 8 of these, so there won't be another round of these boards, and I will assemble them by hand because it's 28 components, and setting up the pick and place for 28 components will take longer than placing them by hand. And I'm not sure if I will even make all the 8 boards. I just want to make a few to give them away to people that are actually trying to do anything with that. Here, where's the C2? I should consider in my future designs to use one direction only for the same components, so there won't be a rotation in between, especially if I want to test it by hand first. Oh, come on. Tweezers are now sticky. Okay. Oh, I have quite some spares here. Okay. That are the 100 nanofarads. The silicon pad has some small cavities. I can put this in. Oh, we can continue there. We have the Silicon Labs ICs here. Let's start. Oh, I'm not sure if that's enough solder paste here on this one and this one. Let's borrow a little bit. Solder paste. Is there some dust on the tweezers or what? Come on. No, doesn't work like that. I'm not sure what to do now. Maybe I'll just grab some solder paste from the tube here. That's way too... I need Johnny's dispenser now. Okay. That should be enough, but this one here, certainly. Like super tiny. Stick already. Okay, yeah, that's much better. I hope that one reflows, but I think it's not even connected, so. Oops. C5? Yes, C5 are 10 microfarads. I will put them next on. But I had the Silicon Labs here. Oh, it's way not not centered. Okay, guess this is all right. Oh, there is no solder paste down here. Let's just grab something and smear it around. Well, that will reflow. We need some more over here. The pads are so tiny. It wouldn't happen if I used like gold plating. It's the cheapest of the cheapest here. Okay. Yeah, it's like a mini PC. And Martin, who I was talking about earlier, that contributes to the VGA lib, he also pointed me to a DOS emulator. He found some open source DOS emulator, and oh yeah, let's see if this will reflow properly. Yeah, that I could use because my implementation of the processor isn't finished yet, and I wouldn't reinvent the wheel if there is a possibility to get one that's already working. Okay, 10 microfarads. Now these are the resistors. Oops. Ten microfarads. This is. And we need some fuses as well. What? Brian, you are up? How did I miss you? Seem to be up here. And why are you going with your dogs in the middle of the night? What's happening? How many do I need? 1, 2, 3, 4, 5, so 10 total. Mario Galaxy, what? I don't get it. Are you sleepless? Okay, where does it go? C5, of course. Sticky. Why is it so sticky? Maybe because I used the tweezers to spread some solder paste. out of view for you. And it was C5. Now we need 12, 14, 13 and 4. Where is 4? Oh yeah, 12, that's the audio. This is the LED. And 13 is there. Okay, so let's start with the audio first. Okay. Oh, we need also here C4. So this we have 2 USBs per board. Oops, that's sticky again. One side of the resistor is flatter than the other. Golden tweezers. Okay, now what's next? We have some fuses to do. Maybe let's continue with these. So I have like 2 poly fuses there. Or I'm not sure how they, no, it's 2 per board, so even more. 4 total. They look nice. Really stylish. Louis Rossmann is always complaining about the fuses. They're probably just rated for a higher amperage. Everything is a fuse. Just a different current. Come on, flip. Yeah. That's what we want to see. Up. I thought to make even more of the boards, but this takes so long. You just keep it with the two here. Okay. That's, oops. That's the fuses here. Now back to this circuit. That's far from completeness here. Okay, we have some diodes. So which way around do they go? Like this? Or like the, oh, I can check with my board. Huh? No, that is the right way. They are really huge compared to the other ones, to the other components. It's been a long time I did placing by hand. This is the connector. Now we need the smaller ICs here. These are some logic gates. It's basically like doing the level shifting and such. I'm not sure if that will reflow properly. But I like the pin, the pad distance here, so the pin pitch. Yeah, Silicon Labs. Okay, now we need the voltage regulator, which is probably a little bit undersized for that purpose here. But I think that one was like 2 amps or something. It's really must, oh, come on. Must be a really low dropout. Maybe 2.3 Chinese amps. Good enough. Okay. USB. Oh, these are the buttons. Okay, let's do the push button first. There should be somewhere, since this spool seems to be complete, there must be somewhere some kind of strip. But let's do it like that. So where does it go? LED, the button. Where's the button? Oh, here. Is this a different style of button here? Wait a second. That's not the button. Uh-oh. That's a different button. No, that one will short everything. I need different buttons. Uh-oh. Okay, let's do USB first. I thought I used the same buttons here, but I might need to check it first. Okay, I'm not sure if I should put, no, it's a PCB. Okay, there is one slight issue with this board already, which I can see, because usually I would need a cutout for the USB connector, because here there's this corner down, it's going downwards, so not sure if it's going with the groove, but it seems to work. It might be slightly tipped upwards. Shoot, I'm not sure where these buttons could be. I have so many trays with components. But we might not need the button. Can add it later if I can find it on stream. Okay. So much to preparation. We are still missing an LED. Oh, come on. We have some LEDs here. Okay. I'm not sure which way around. This way, oh. Okay, this way around. What do you think? Oh. Sorry guys. I can show it again. Oops. Okay, so I got this LED, and on the bottom, I'll turn around. Okay, so the pointy thing goes in this direction. Yeah? Or are you answering Brian to someone else? Okay, I might check with my other board. Because there is like an indicator in the corner here. Let's enhance. Oh shit. Oh, I can get closer without it getting less sharp here. Okay. And now zoom out again. Let's compare it. Because that one is correct, and it seems so this one is pointing in that direction, that one as well, so this should be right. Okay, that was the LED. Now next would be maybe the micro switch. That is certainly needed. Even though it's not rated for the current that we are using it with. But otherwise we won't get any power. Cool. Okay. Now only the headphone jack, the SD card thingy. Let's start with the SD card first. With the rover modules. With the streams my channel is getting, or my both channels are getting so much view time. When I went offline on the main channel yesterday after 6.5 hours, it was already 700 hours of playback time. It said, not that I would care about that, but it was showing it directly on the screen. Yeah, now it's stuck. No, damn, we smeared everything there. That will be some rework. My hand was too shaky, or it was like too stuck here. This is alright. The huge USB thingies will be oh, we have to get rid of this, I think, because we are using the rover modules. Or it might, no, it doesn't care, but I don't want it to be the solder to be like pressed out there. The pads are, this is like a footprint that supports rover and room modules. So, and that would be, these pads would be for the room module, and the rover modules are up here. Other than that, they should be compatible. How do I place it? I need wider. Let's do it like this. Oh, have you even been able to see it at all? So what I meant were these pads here. I cleared them because these are for the room module, and they are basically the same as these here. So you can even see the connection here. So the trace that's going this way. It's just a little bit of a different layout, but other than that, there is on EasyEDA. You can search. There are some user contributions that have with a shared footprint for. What am I doing? Wait a second. Oh no. Smearing everything. Crap. Is this even the right one, or is it an S2? Oh, come on. That's the right one. Okay, we will have to, I will just press it on. It's a little bit tilted. That will be crappy. Oh. Let's do it. That one, it's hard. I will just use my hands. That's much more precise than fingering around with this tweezers. Yeah. Now a little bit of a shift on that side. And it's aligned. Give it a nice squeeze and press. Maybe poke it to this side. Okay. Headphone jack. Oh, we are also missing the host chip. The expensive ICs, the parts at the end. So the rover module and the host IC. Oh, did I touch? Oh, it's hard to not touch everything. The last time I made these, I had to fix some solder bridges on that IC as well, so I wouldn't wonder that if that happened this time as well. It has really to be aligned properly. think that looks okay though. Yeah, I told you, Sion, I will buy your charm high for twice. I doubled even my offer. Oh, is this saliva? I just spit on my board here. I doubled my offer for your charm high last time, and I will double it again. So we are at $4 for the charm high, but shipped, please. So I take it for $4 with shipping. $12. What? Ah. I would imagine, Sion, if it was without shipping, he would even consider it just to get rid of the huge thing in the driveway. Throw them on the floor. Yeah, but my projects lack in sophistication, so the charm high might even work there. Okay, this component is that's the one that's most difficult because it's out of plastic, and if the reflow profile doesn't work, so this is like a so low temperature solder paste. I just need to get some of the paste on the top of the pad, otherwise it won't stick properly. It looks awful, but I will have to reflow it again, or no, that doesn't work. Or I can put some soda paste. Just, don't I have a syringe here somewhere? Doubling. Okay, no, that doesn't work. I will do it later with just soldering iron. Let's put it on and reflow it soon. I will just check if I can find the other button type, otherwise we have to try without the button first, and I can still add them later. Okay, let me check. I have to solder the VGA anyways. Let me check quickly if I can find any buttons here. There is a button, but that's another type. unfortunate because I took quite some time to prepare all the components, but unfortunately that wasn't the right one. I have all kinds of buttons, but not this one. Yeah. Okay, let me check one last time over here. Okay, I'm almost done. Okay, if it's not in here, then I have no clue. I found some wider tweezers. That might help. Okay, these are connectors. It's only headers. The problem with the buttons is that I probably have shared them with different projects and put them in some project box, and now it's lost. No. Not in here. Okay. Never mind. Let's try without the buttons. I will reflow it, and did I miss anything except for the button? No. Good night, prop. Okay. Yeah, let me get it in the reflow oven. I have no clue what kind of profile that is. It will either melt the phone jack or whatever. I can replace it. Back at this thing here. We didn't have such a big field of view yesterday. Oh wow, the 4K resolution is quite good. It's really unfortunate that I can't use it with real-time chat. I like the translucent green. I ordered another resin today. It says clear. I have no clue what that means. If I would really love one that's like glass. Someone suggested to print actual like closed cases. Yeah. That was yesterday on stream on the main channel. I tested the Anycubic printers. I got like 2, and I'm also giving one of the mono I'm giving away to the best suggestion what to print with that on my Discord, and the other 2 go to makerspaces that have like open hours to the public and that lack in funds for such a thing. Yeah, I hope that works out. I have to check the Discord. I didn't read much today on Discord. I have to organize it more, to put like a list or something so people can vote, or maybe announce it on Twitter as well, because it was like in the middle of okay, it was in the beginning of the 6.5 hour stream yesterday, so not everyone will watch it, and I'm not sure if there will be even applications for the printers that go to the spaces. Resin fume sniffing marathon, yeah. Now they are standing in the next room. I will check if it's ready or with the reflow. Oh, it's at the peak. Unfortunately, it's infrared reflow oven, so not so fancy like Xeon's. So that's why the dark parts, like the plastic connector, will melt. I found a sweet spot once, and in the reflow profile where it was properly reflown, but also the connector wasn't melted here. I will switch for a different connector. I don't like this. I have to rework that every time, because it doesn't reflow the solder on top, and if you push too hard in, even though there is like plasticky here the things you can see, it's still if it's like that, it's pushed to the front, that's bad. I think I did it wrong again. Then it will detach. It doesn't break the pads, fortunately. That happened quite a lot of times to me, and I was able to resolder it. So I got different ones that need to be soldered by hand. Let me get the others. Oh, I think I saw them here somewhere. Yeah. So the true hole on the true hole audio jacks should be better. Okay. Let's take a look what we got here. So, not sure if the reflow happened properly. I see no, it didn't. I think I have to, no. It wasn't hot enough or didn't soak enough. You can still see like solder balls. No. I can already see there a bridge at the USB port there. That's cool. You plug it in, the world will explode immediately. Ay. That one looks okay. Yeah, we'll put it a second time into the reflow oven. That will solve a few of the issues, I think. But it was like here, that doesn't look great. It's not properly reflown here. It's too bright, isn't it? Look. It's not like, doesn't look great here as well. Let me try again. That's hobby level reflowing. Oh. Look at this. Here. The resistor that's so tilted. But it works. It's way too much solder paste here. Is that one even connected? Yeah. That's the one that I did before. I think I fixed that by hand here. That one. Can't imagine that there was so much paste on. Yeah. The button also looks like a cold soda joint. Almost. At least no soda bridges here. I'm not sure if I tested everything on this board. Makefabs, yeah. Makefabs asked me again if I want to do some sponsoring for them. I will if I have a project that's worth mentioning again. Just get a second N8. Yeah, Xeon will scale up at some point. I didn't hear a peep yet. Scale down 50-50 right now. What? Once the first N8 pays for the new garage. Yeah, I better get the soldering iron out because we will need it. At least we get some soldering today. Where are the buttons? This wasn't probably a huge amount of these, but only like this. We just need another 2 minutes for the reflow oven. I can take another look here. No, can't find them. Not sure if I even have any left. Oh, wait a second. I have a shelf with small buttons here. SMD buttons. Maybe there is some kind of button also here. No. All different types here. I have all kinds of small buttons, but not the right one. like a complete bag full of these here. Unfortunate. Okay, the reflow should be done now. Okay, that looks much better. The soda actually melt this time. I might touch up here and there. Soda balls here. Ooh, that doesn't look great. Yeah, that was that smeared SD card holder. And there was quite some excess soda paste here. Oh, that doesn't look great. I'm not even sure what I see there. Let's zoom in. Enhance. Yeah, no, I have to clean that up. That's not good. There are some soda. Maybe if I put that into the ultrasonic, there's a bridge. There are two bridges. But it's not that bad. I could put it right away in the ultrasonic cleaner. There are some bridges, and fix anything else later. Yeah. Okay. Let's take a look at the USB stuff first. Oh wow, that's a huge blob here. But we have enough soda here. There's still the bridge. It still looks a little bit crystalline. I'm not sure if the temperature was high enough. There's a cold solder joint. Oh man, I will just take my soldering iron and fix all that right now. Might need... One continuous swipe, okay. Yeah, and I should only order gold-plated boards because it's like the surface is a little bit rougher and the soda paste sticks better than this hot-aired stuff here. Okay, let me get some... where's my soda paste? have a nice dispenser here. Is this the proper amount of flux? Anyone please go ask Louis Rossmann. It certainly helps. Is it okay? Let's zoom out again. It looks much, and it is, but it was like super overwhelming. Okay, I need now. Let's leave it like that. We need some more sharpness here. Give you more sharpness. Yeah, there's some excess solder here and there. Oh, that has a different smell. I'll get cancer again. Okay. Oh, yes, that's a bridge. Okay, I think the bridge is gone. Just submerge everything in solder and every problem will solve itself. Here there's a cold solder joint. There is not enough solder. I'll just move it a little bit around here. Bloop! I don't even need to put on new solder. We'll just take this bismuth based. Huh? Oh, there's enough solder here. How do you like that? Okay, that one. Oh, can you even see it, what I'm doing here? Just heating that up. More light. Everything is submerged. Despite all the stuff that I did for setting up a proper lab with reflow oven and pick and place and whatnot, at the end I must admit that I rather spend my time a different way than manufacturing here at home. So I rather use order at maker fabs and let them do the dirty job. I don't have a syringe for that. I'm not sure if I have enough cleaning solution to get rid of all that excess solder paste here. or soda flux. Okay, let's get rid of the solder bridges here. Just pull them away and clean my tip. Why is the image so much worse? It's like looking through the eyepieces. It's so much cleaner. It's like the optics are way different. I can't get rid of this here. So I get some wick. But the wick is, oh boy, it's like the wick. It's like a complete hairdresser here. Not sure if that will heat up enough. Come on. Did it wick anything? It needs quite some time to heat up. That wick is way too huge. Okay, we got rid of a little bit. Come on. What is happening there? What's my temperature? It's high enough. Okay. No. Doesn't want to do anything. PCB way, yeah. PCB way also assembles stuff. But I also like the personal service from Maker Fabs. Maker Fabs is more like, oh yeah, there was a lot of solder there. Maker Fabs is more like, here is my wish, and they make it come true. Like, okay, they will not do everything for you, but if I tell them, can you get me a part that's doing that and that? Or can you, here's my design, and substitute the parts with similar, better available, cheaper parts, and they will simply do that for you. So at the end, if you know what you want, you have like a super finished and product, you can go to PCB way. They have certainly good quality boards. Come on, there's still some solder left. What's up? Okay, let's heat it up. Heat it up. Somehow I don't get the solder out there. Is it so much soda there or what? Ouch. It hurts already. The wick is the wick is actually hot already. Not sure, the two pins aren't used anyways, but if there is like a power pin or something. Sorry guys, I can't look in the chat. But if you highlight me, I can see it right away when I'm looking up. Somehow this soda bridge won't come out. What's happening there? It's like the sweet spot of, it's like a soda ball that's hovering there between like the pads. Let's get rid of these bridges here. I need a break. Look at this. Some excess soda here. Same thing there. Let's move it a bit. Maybe we can move it to the side. Yeah. It's another trick. Oh no! Moved back, but it's less and less excess soda. Xeon want me. It's too much soda paste. Now we struggle here. I thought that was quicker last time when I did that. I should use a different light for that. I don't like the direct light from the top too much. More flux, more heat, all the above. More soda. Yeah. I don't think that the heat is the problem. It's rather too hot already. I have 330 and that is low temperature soda. Okay. Let's get some soda on. Blended soda here. Oops. We shouldn't mix, but I will anyways. Now it's crystallizing. No. At least we can see it now. Okay, let's do the wick. Ah, that worked. Okay, great. Now let's just continue with these here. While the wick is still hot. Oh yes, please. I wasn't patient enough. More heat. Okay, I will turn it to 350. There's like a ton of solder paste between these pads here. Look at this, how much I got out there already. Come on. Okay, we don't get the surface tension. I need to add a little bit of solder probably. To suck it out. Ouch. Burn my fingers a bit. Yeah, I added even more bridges with. Let's take a fresh piece of the solder here. Solder wick. Come on. The wick is sweating solder. Okay. I'm melting the compartment of the wick. Okay, I'm not so patient. You never gotten, maybe add some more flux. No, more flux doesn't help. Oh, come on. What's going on? Okay, let's clean off the tip. We moved it to the outer pins. This is getting embarrassing here. It's like a huge amount. I need to clip my wick a little bit. I need half as much heat if I use the tip because it doesn't need to heat up the wick in both directions. You already see. It's absorbing something. Yeah, look at this. This is how wick is working. Okay, let's try. Oops. Let's try to remove these bridges here. No. Need to rotate it. Okay. Cian has the best I told you moment. Right now. Oh, that's like a huge amount of solder under there. It looks much, but it's like really small. The pin pitch is 0.5 millimeter. You lose the sense of size looking all the time through the microscope. This like this solder ball is hovering. We need to get more out. Tiny, oh yeah, tiny bit of solder, and then let's try. Teeny tiny. Yeah, and then we have a huge blob of solder there. Okay, now the wick is absorbing. Just keep it steady. Maybe moving to the fresh part of the wick. Oh wow, it's bone dry now. Cool. Okay, that worked. That's how the pad should look like in the first place. Okay, touch-ups here. That's all right. This is all right here. How about this stuff here? I think that's looking okay. It's a little bit too bright for you. Just heating that up a little bit. Doesn't look so clean. Here as well. I might add some solder here because I don't like how it looks here. I want the pad covered. if you could see anything, huh? Let's heat up the complete shield. Yeah. Okay, I can't get it better than that. I don't want the solder to get in the, or even melt inside of the SD card holder. Yeah, let's clean that up a little bit. Yeah, that looks much nicer now. Okay. How about this? The module here. What do you think? Leave it like that? Let's take a side look here. We can even focus that high. Yeah, there is some kind of connection. I don't think I need to do anything here. It doesn't look like super nice, but it's reflown. Yeah, I also think there are too many flavors of ESP32 or ESP. Okay, we got this board isn't done yet. Okay, so we have that one covered. I think that was all here. We fixed that. Here power supply is okay. USB was alright. We did the pads. LED looks okay. Okay. Resistors, some stuff here. Did this even reflow properly? Yeah. That is also alright. Okay, let's do this side. Okay, that was probably the connector that wasn't smearing around. I think this is good. I will add, oops. Oh. Okay, my eyes can adjust, but yours can't. Sorry. I will add some solder anyways to get here like, let me get it this way around. Get some nice solder bridges here. Oh man, what did I do? No! There's like, okay, there's quite some solder in there. Let's put it here. We have some excess solder that we can put on here. Okay, we need some flux. Getting old. By a hoof tip. Yeah, unfortunately, I don't. This soldering iron is discontinued, and there was never a tip for that, like this cap where you have the drop inside of the tip. So I just got like there was the one company, Reichelt, from Germany, that had still some tips for this iron. I can keep the station, it is 100 watts, but I would need to change the handle, so the actual soldering iron for a new one, to be able to buy new accessories. There is probably some knockoff Chinese things that would fit this soldering iron, but I didn't try yet. It wasn't so urgent. It doesn't happen often that I solder much here. That would need like such a precision. Oh, this side looks great. Okay, do we have anything here? No. This is also flawless. Here we have only like 2 small ones here. Okay, gone, and come on. Okay, I won't be able to get this one. Oh, no, it's here. That's too much excess here. Can't get it off with the tip alone. It's like super much rework for only 2 boards. Oh! I got it here. By the way, is the new season of Expanse online already? Where is it? Where is it airing? Or was it only announced? Oh, this is awesome. I'm able to just pull off bits of solder here. This is cool. Okay. Not sure why the LEDs don't reflow that well. Whack-a-mole. What? 30 pounds. Yeah, pounds are it's more than dollars. Okay. I just want to get this. Oh, wow. That connector is... I must have knocked it off while carrying it or something. Didn't see that at all. I mean connector, the switch. I'll just reattach it simply. I need a second tool to press it down. hope still works. Let's help a little bit. Ah! Oh, that was a good laugh earlier. That's soda paste. Paste. I mean flux. Okay, there is no short, no bridge in the USB. The serial also looks fine. I like what I see here. It was like the right amount of paste here. Okay, let's get a few. It's like very steep here. A bit more solder here. Oh, come on. Oh. Yeah, that's the right amount there. What the fuck? Oh. Yeah, share. Now looks better. Okay. Oh, is it still zoomed in? No, but you're not in. Oh. I will add some solder here as well in the corners. I don't like what I see here. Here's the center, okay. Interesting, the camera center is not at the same. Oh, cool. Are the pads even connected? I'm not sure what I'm doing here. It's a little too much. Okay. That's good. That one is not connected. I can see that you can't. That is probably the ground pad, and that didn't succeed to reflow. And that was the same spot we saw on the board earlier that I did last time, where there was also a problem. I think on this side it looks a little bit sketchy. Flux. No, I don't want to put more flux there. Should be enough here from solder itself. Heat up, heat up, heat up, heat up, heat up. Yeah, it worked. Yeah, that's a ground. I can tell by the time it takes to heat up. But this one looks okay. I don't see a problem here. I will reflow it as well. Oops. So just to be sure, that's not... That happens on the ground. Okay. Has this result sold you on the idea like electron ash? What? Ultrasonic cleaner, yeah. Let's clean it and look what we got. Let's check last time here. Okay, I will put it in a cleaner. And then we see, oh, there is a bridge. I still see a bridge here. Okay, gone. Here, and here as well. What the? How did we miss that before? Come on. Is it that time again? Didn't we fix that side already? I need the proper angle here to get the surface tension. Wait for it. Wait for it. Wait for it. Yeah, that's right. Here is another one. Come on. I can move it around, but it won't stay at one pad. It always like only jumps if I get another bridge somewhere. It's like too much solder here. Let me dry my tip a little bit. With that reflection of the light, oh, now you can see probably a little bit better. Can you? Okay, that one won't come out again. I need the right angle here of the tip to give it some good surface for the tension. Okay, wick. Can actually see this. Oh, see this time. Yeah, it moved down, but it's still there. I think we got some away, some solder. We can maybe manage to get that bridge off even without wick anymore. No, we can install even more bridges. Patience. 3, 2, 1. Yeah, nice. Okay. We got that. And that's also, oh no, there is one. How, what the? Now it's gone. Okay. Okay, that's the hardest part. I certainly don't want to do that many more times. Okay, let's add the USB connectors here. Didn't I prepare some? And the VGA as well. We will at least test if it's recognized as, if we can program it as a ESP32. I don't have testing software ready. Here, in the back. Okay. It's hard to get work done. Yeah. You know what? I really enjoy that we can do this right now, because otherwise I'm not so motivated, as you might have already seen since the summer. I lack a little bit in not motivation but drive, I would say. And doing the live streaming, I can actually get the concentration I need to get actually some work done. Nice. Cool. Oh, I know what we need the button for. The button is to puts the USB host into programming mode. Yeah, but we can simply short it as well. We can use it like a screwdriver for that. This is the mini game console with composite? No, it's not. It's a mini computer. You came later. I will show it in a minute. Here. Not composite. It's a D-sub connector. Oh. We need to split it right now because here the switch and the VGA doesn't go together. Okay. You are not able to see anything right now. Okay, let's do the true hole stuff. We have certainly, well, my fingers are sticky. No, certainly quite some flux all over the place. At least I smeared it everywhere. Yeah, ESP VGA computer. It has two USB host boards, VGA, and an audio jack out. And is that all? Yeah, I think it's all. Oh, I love how this is reflowing always, like whew. Get this in your view. I couldn't count how many of these connectors I have soldered already. I stopped offering assembled versions of my VGA boards except the tiny Pico board. I think this one can still be ordered completely soldered. And that was also the last one that I was soldering. Everything else is only kit only now. I had a premium price for the assembled version, fully assembled, but it was still, I don't know, it's not like about money. I don't make, like, the work is more tedious doing all that Tindy stuff than just cranking out another video or something. So it's more a service for the fans that actually are interested in that stuff. And for example, there are not many things that I offer on Tindy anymore, and the camera programmer that is completely assembled by maker fabs. So, and that's not a passion project. That's also only service to the world, because the camera modules are really pain in the ass to program. Oh, we need also this here. Yeah, that's it. Look at this. I was here. DOS board version 0.1. I have started to implement an 80. It was 2086 processor. No, 280 280. So I started a CPU emulator and BIOS emulator, and it was already loading the boot sector, but I implemented like each instruction of the x86 processor when it came up in the code. So I loaded like the boot sector into memory, and then interpreted every single instruction by instruction, and whenever, and I did this even in Arduino, so the execution simply stopped when it came to an instruction that it didn't know. And I got it as far as that it shows on the screen, it displays on the not on the screen, on the console, that it failed to load or something. So there was even some string functions and calling an interrupt, text output BIOS interrupt, to display the message of the failed bootloader. And I think the problem with there are so many things in the AT or XT design that needs to be properly set up before the system can actually load, because there is like this memory region in the start of the memory where the BIOS is putting all the values in, like what hardware is installed and such. And I think I missed a point. What I would need to implement is any access to that region of the memory should be alerted as well, so I know which values this bootloader needs to access to load the other sectors of the from the disk. But I know there was, I think it tried to load some sectors, because I also implemented one interrupt that was loading disk sectors, but I don't remember much more than what I did there. Okay, I think this is the first one is done. You get dizzy now. The interrupt handling isn't very bad. It's like only the first 4 kilobytes or something are reserved, or how many are reserved for the interrupt vectors, and you can simply just overwrite them, and then you can call the old one from within your interrupt. But I have the benefit that I'm the processor. So when there is int hex 10, then I know it tries to access the functions of the display or something. So, and there are like all the interrupts are known. So I can I interfaced the system at the BIOS level. So what MS-DOS does at the end, so I tried to load the boot disk and MS-DOS 3.3 boot disk, I think it was, or was it 3.0? What it does, it only adds some interrupts that at the end simply handle the file system, but the actual access to the disk or hard drive is done by the BIOS. And that's all documented. So I can do some actual handling within the BIOS interrupts. So like, for example, my emulation of the graphics card for VGA can be done in that interrupt handler, and so there is no actual BIOS. But I'm not sure if this is the right way to go, because there is also, like, quite often, I did this as well, hardware is accessed, like setting the palette of so the colors of the 16 color mode or 256 color modes is done either by calling BIOS interrupt, or you can output it, or use the out assembly code. So it's a hardware access at port 767, I think. 766, you could set something like that. It's like what, and you can set a palette there to write it to the graphics card directly. Oh, I did all the soldering without thinking about it. I'm just talking all the time. I did so much stuff in DOS, I'm very confident about that, but there is a lot that the BIOS is taking care of, and I'm not sure if I want to re-implement everything, especially initializing all this information block of the memory that the system can access at some point. I'm not sure about that. It might be interesting to try only to emulate at the hardware level. So only like the opcode, out and in, and then just use some kind of ROM based, not ROM basic, some ROM. It's only like loaded from the disk and use it from an old 80 or XT PC. I have seen some implementations of DOS emulators. There is one, I think there's one that even runs in a browser, and I think that one even takes a ROM image of the BIOS, so it doesn't do the emulation. Or it simply overloads the interrupts later. So loads like runs the initialization, and then when the boot sector is accessed, it implements all the stuff, but I'm not sure. I'm just waffling here. Okay, we are almost done, I think. We sorted everything. This one is optional. I added it, I think, this header added later to be able to debug something. Okay. Oh, this needs some ultrasonic cleaning now. Oh, I'm wondering, did we lose connection at some point? Because I don't know if there was my 24-hour reset of my internet connection already. Ooh, that cleaning solution could be replaced at some point. Doesn't look very good. No. Okay, one board at a time. They are quite huge compared to my ultrasonic cleaner. Now I have some time to read what you have written there. Phase. Whew! Haha! Software interrupt. You need a manufacturer for this board. Yeah. I don't think this board will get much simpler. I think we get the new C3 chip has also USB device included, so we get rid of the complete section of the board. Let me show this. Oops, here. Why is it so huge? Okay, so this section is only serial, USB serial. So we will get rid of that part completely. So it's only a few ICs, and there is another footprint of that IC, but if we let it taken place by some another company, and that's only resistors and this module, so there is not much to it, and these are like the most parts here that are like very different kind and such. Okay. The rover has PS RAM, I think. Yes, it has. Okay. Yeah. I have to scroll back. Ash, what you are? Oh wow. 286. DOS Prince of Persia, yeah, or a Master of Orion. Box BIOS. Oh wow, yeah, 486 is another level. So with the 386 you got the protected mode, and that's like the James Sherman. They had to cascade 2 pick chips, so the second chip triggers RQ2 on the first. And then the PCI has 4 RQ pins per slot, but each slot kind of shuffles those signals. Try avoid sharing too many RQs. Crazy stuff. PCI config stuff wasn't quite as scary as I thought. Okay. Oh, okay, yeah. Okay, so yeah, I didn't do paging now. I have like what I did was allocating a chunk of memory, especially on the smaller PCs. You didn't have like a huge memory block, like 640 kilobytes. But I would do memory mapping with the PS RAM for the emulator in future. So I can do like the VGA address or text mode address was C8000, I think. Yeah, I would have to map that obviously. So actually doing that already enables me to implement also like protected mode if I want to, because then there you have also page mapping, so memory mapping with pages or EMS memory or XMS memory. There are only 3 people left. Oh man, Brian. So late up. Yeah, I lost my language here. Okay, I flipped the board and it's already 3 hours stream. How long is this stream already? Oh yeah, 3 hours 10. I thought it would be a 2-hour stream, but we had quite some problems. Yeah, Gates 20, A20. So Pentium bug. I open the window for a bit to get some fresh air here. You know what? TapWorks OS. I don't know TapWorks. I know PovRay, the ray tracer. They didn't get to put the first level cache on the die and had to make a PCB. What? Oh yeah, I remember. But AMD's. I had an AMD CPU that was also on a cartridge. I thought that was a cool design because it was easy swappable. Oh, you know what? I could grab a snack. I have still some snacks that David Watts sent me. Here, dark chocolate. Let me switch here. Face cam. So we have Burnville, and we have fudge. I like these. I had quite some of these, and I kept one. But I want to try the dark chocolate today, at least a part of it. Oh, it has some pieces. Oh, Bourneville. Thanks. Like the Bourne identity. Aaron, are you from Great Britain? Wash my hands. I just did. I wiped it with with glass cleaner. IPA. I thought it was like bitter or something, but it isn't. It's quite sweet. Let me check the ingredients. Oh yeah, okay. Ingredients: sugar, cocoa butter, cocoa mass, palm oil. It tastes good. I will keep the other half for later. Okay. I unfortunately ran out of IPA because I used it for the washing of the... I switch to the other camera. Here, potato cam. To wash my 3D prints yesterday. So we might get some stains on that one. Oh, I can start to wash the other one. Where is it? Here. Now it looks okay. Okay, let me get off the corners here. Okay. Let's check it out. Looks good. Most important thing is not to short the USB. Is that what kind of gunk is that here? Oh no, that's nothing. Yeah, that's the one that came off. It's a little bit dodgy, but is it still working though? Flip. Yeah, it seems so. Oh. Yeah. I touched it with the soldering iron here. Yeah, I couldn't. If that was a product, I couldn't sell it anymore. It's like here. It's not like completely broken or something, but it would be a quality issue. It's just a little bit mold in there. Cool. Oh. Let's show the chat. Chocolate solder paste. Okay, we only missing one button, and let's plug it in and see if the computer dies. I have a USB. Oh, I will use my USB 2 port. Not that I kill my USB 3 controller. Where's the USB here? There. Let's wait a minute. No, I will turn the ultrasonic off so we can hear if the PC recognizes the board. Ah, the LED is lit, so this also works. Now, oh, that's what I mean. I need to rinse it with fresh IPA, otherwise I will always get the stains here. I ordered 5 liters today, so a new canister of 5 liters. No, I don't need a button for the ESP32 has a reset circuit here. This small IC does the reset here, the H3. That has the reset circuit only to program that one, and that was the button for. But I can simply short it when I want to program it once. So that's optional. And to program it even, you have to connect it over the USB-A cable that has 2 USB-A things like that, and one, I think this is the first port here to the PC, then you are able to program it. But I won't do this today. I have to, I'm not sure if I even have the compiler or flasher on my PC right now. Okay, let me clean this board for another minute. Let's program it, I would say. Back to Potato Cam. Potato Cam. Let's turn it off. Oh yeah. Okay, I had enough fresh air. Arduino. Maybe I can find the DOS compiler, but that will the DOS interpreter, but that will require an SD card, I think. I'm not sure, or some spiffs or something with the boot sector. Okay, screen sharing. No, I will just. Oh no, no! What? No! Ah! It's broken! Let me move that to OBS to that side. That's something else. Yeah, you won't be able to read that, won't you? That's much better. Okay, so tools, ESP rover module is selected. You can't read this, but I will just take an example and example for the rover module. Ooh, SD. We can test the SD already. SD test. Okay. Select the port, it's 5. And program it. And then I need an SD card, I think. Do I have a nice SD card here? Guys, I found just on my desktop, I found the first version of that USB host. Look at this. This is the first. This is a horrible quality. Okay, here. I just used the perf board, soldered on to USB A ports. This is my the USB ESP program. No, that's like a serial programmer, or only a serial to USB to serial. And here, that's like a breakout board with the IC, a button, and a LED. Just to program it and test it. That was the first version of the host IC. Okay. Let's take a look at the desktop again. And do we have an output? Serial monitor. Okay, I just turn it off and on again. Let's see what it says. Does it say anything? Uh-oh. No, it has programmed, but I don't see anything. Is there an output? Setup. No. Test file setup. No, serial begin. It should write something. It probably... Okay, let's just program it. Because then it will not output before the USB is connected again. Oh yeah, okay. Entry point, card mount failed. Okay. The ESP is working already. We can check. Oh yeah, I found. No, that's only. I need a micro SD card. Is it? Yeah. It's a micro SD card. I have a micro SD card here. Yeah. Okay. I got a micro SD card that I will connect to. I'm not sure if this is even the right. Okay. I'm not sure if these are even this is the right configuration here, which GPIOs I have used there. So let's try again. No, card mount failed. It's probably a different card SD card configuration. Oh, okay. We have another thing. We have example. Maybe it's the SDMMC. There are two different pin configurations. Add 1K pull up after flashing. D0. No. This. I'm afraid I will break something if I use it just without configuring the pins. Let's see if it does anything. Where's the output? No! I missed it. No, I missed the output. Shoot. Let's try again. I need to open EasyEDA to check which pins I connected. No, card mount failed. Okay, let me check my design. Where is my project? We have so many mini VGA kits. VGA dev board, no. Shitty add-ons. I need, no, that's not the one. Let's check. That's VGA. Oh, it is. Yeah, we were lucky. The sheet 2 is, yeah, that's the serial port. And this is, it's called VGA Blue, and I saw that on the black VGA. Oh, sorry. Okay, so let's check the SD card. we have miso, mozi, and stuff like that. So which card implementation is that? So it's an SPI. Can anyone remember how that worked? List here, setup. Let's check setup. Oh, it only says begin. What was the other one? SD test. I just need to use another pin configuration, but I'm not sure where to set it. SD card mount. There's no definition here. Impossible solder bridge. Okay, you know what? We can try, but I don't see a solder bridge there. That's really perfect. I can show it in the microscope. The SD card, or there might be a bad connection on the. Look at this. This is flawless. There is no solder bridge. Where's the solder bridge there? Yeah. Maybe a bad connection on the module, but it doesn't look like that. We can try the other board though. Not sure. Maybe it's the wrong file system. That's an 8 gig card or something. Yeah, it was. I won't try to fix that. Let's try the second board. Okay. Pew. So I will test this off camera completely, or at least write some software for this. This is the second one. Oh, I can see a solder ball there. But we can probably remove it without the soldering iron. Here, where was it? Yeah. There is a. It might be only a ball. Not sure if I can remove it with something I can see with my bare eyes, but I'm not sure now. The tweezers are not pointy enough. Oh, it's gone. Okay. SD card looks okay. module. Yeah, probably works. Yeah, still some gunk on here. I really need to change my fluid. Oh no. There's some gunk. Proper amount of flux, huh? This is looking so huge on microscope. Is it blown out? I need another lighting. I think Steven has like a good setup for the microscope. He doesn't have the ring light, but he also uses only, I think, a digital microscope. Oh, the USB is close call. There's some kind of saw down there. That is okay. There's a dry pad, but it doesn't matter. It doesn't connect to anything. That ground looks really dodgy. Okay, cool. Let's connect it. Let's not talk too much. We want to get some sleep tonight. Tonight. Ha! Good joke. I can't believe I have now 3 of these boards. Smoke or not smoke? Okay, it works, it works, it works. Let's put in the SD card here. And let's try the normal SD test. But I'm sure that I configured different pins. Wait a second. CLK Mosi Miso. It should be this one here. But not. Let's check the UHD desktop there. So we have, let's compare the pins. We have CS, so chip select should be SS here. Chip select 15, yeah, that's not right. D3. Oh, wait a second. Is this like an Arduino code? Strange. Okay. This is MMC. D3, no. Yeah, let's try it. Let's see if it programs at all. Oh, is it a different port? Yeah, it's COM6. Uh-oh. Well, there was an error. Card mount failed. Okay. It was able to program. But SD card, I need to check what I used that before. Where did I put some code? I don't have a nice view here. I need the second camera. Second, third, and whatnot. Just like Xeon, I need more cameras. You can never have enough cameras. Cool. I have 3 of these mini computers now, of which 2 will be given away. One will go to Martin, and the other one I don't know yet. Someone who contributes in the libraries. Ooh, what's that? It's okay. Okay. I need to solder more stuff that's a little bit simpler that I can simply give away as a Christmas present to you guys. Yeah. Okay, let me check my code if I have something for the DOS board. It's here. Test files. Data. Disk image. Oh, interesting. Shall we take a look on the code? I will copy it to, not sure if that works from the drive, from the network drive. I will try. No, that's emulator. Oh, okay, I need it won't show the code. It's like I developed it probably with yeah, studio code. Oh, I can zoom in, sorry. You won't be able to see anything here. Let me just start Visual Studio Code, but I need to switch so I don't share too much. No, it's only Visual Studio, file, open folder, code, DOS board. Okay. The font is way too small for you guys. Okay. Source code, emulator. Yeah, that's side sector. Okay, that's the interrupt. I implemented hex 10, hex 13. So video mode, switching video modes is hex 10. The interrupt hex 13 is drive access, reading sectors. Then we have keyboards, reading strokes, hex 16. Hex 19 is system start, so it's a reset. And program termination is hex 20. 21 is debug. It's like it would call 21 is the MS-DOS interrupt. And so what do we see here? CPU. Oh yeah. That's like here. That's a map of for the first byte, for the first opcode byte, a map of the instructions. You won't be. I'm not sure. I can maybe. Let me change the scale here. Maybe that helps. Yeah, that helps. So these are the opcodes, and I'm simply saving the address here, and No, where is it? Yeah. And for each opcode there is a separate function, and something like add and call clear byte word, no, copy byte word, no, irgendwas, not implemented. There is like, this is like this default case. It's not implemented, and that will drop like in the exception. Here compare, there are some cases that are implemented, some are not. And I'm only implementing as the code requires that is running currently. So least amount of work, but it still didn't work. Let's try to program it. Is anything connected? No, it's not. Okay, here. It's connected board here. Okay, tools. Can I reset again? No. I will program it again. I'm not sure if I need to upload spiffs or something. Oh yeah. Okay, so we got okay, so I have another reserved sectors, loading 215 bytes from disk, not found, add is not implemented. That's like the boot sector is missing, I guess. So there is a missing boot sector, but that's how it looks like if it tries to run in the opcode. That's, yeah, opcode 0. So it wasn't able to load the sector, and I'm not sure if I am able to upload the spiffs here. Yeah, but that goes too far for now. That's it for today, guys. I didn't read the chat. I read the chat now. Emo init, emo boot, yeah. CD-ROM controller. Oh man, that's a lot of text. You guys were talking. Okay. I think this is enough for today. We had a blast. I had a blast with you guys that you joined. And yeah, we have some kind of working board. We need some code or to properly test them. Now, would be cool to, I think this one has already this serial host programmed, and would be cool to have like an output on VGA at least, maybe loading graphics or something from the SD card, and keyboard and mouse from the USB ports, and maybe audio out. Then we have everything in place, even though it's not an emulator, just as for a showcase. And then redesign it, simplify it, maybe for the S2. S2 doesn't have a lot of graphics power, but this is only like 8-bit for the complete VGA, so it's like 4-bit per pixel anyways. Is it? No, it's not. It's 6-bit per pixel maximum, but then we can do EGA modes or something, only 16 color modes or something that would fit in the SRAM with some stuff, I don't know. Yeah, either with the S2 or with the Beta C3. If I get the kit, Jeroen already contacted me via email if I want a new dev kit for the new ESP processor, and I I obviously agreed because I wanted to see what they implemented there, and I checked the documentation today. At least I found a draft online, and yeah, it's unfortunate that there is only one I2S, but it has more memory than the S2. That's great. It's like, I forgot how much SRAM it is, but it's better, and it has USB as well, and it will be cheap. So we get a mini PC probably with the newest ESP. Cool. No, it's not. But I have like boxes of hardware with that could make it possible with an extra IC, but they cost like extra. It's like the IC that does the serializer IC costs almost more than the ESP itself. So and I didn't get it running yet. I didn't try. I ordered the parts and they arrived. I have somewhere a box with all the parts. I think this is the one. Yeah, that might be. Or is it the box with the FPGA stuff? Let's take a look inside. This one should have some expensive ICs, because otherwise I would order a real. Oh wow, no. What? That's an ARM. STM32H750. I can't remember that I bought them. Look. Beauties. So obviously I did. Yeah. ADV 7513 probably. Obviously I bought all the parts for an STM. What is this? Oh, Atmel ICs. Okay, that might not be the box for the VGA stuff, HDMI stuff. But they are. Oh yeah, that's some audio stuff. Oh man. Okay. Yeah, but that's stuff for another time. LuniPi. No, I really don't want to do a LuniPi, because why should you? If you want a Raspberry Pi, then you can buy the Raspberry Pi Zero and you got this. No need to get like super limited fake Pi. Butter Pi. Ah, you know what? Wait a second. I have yellow boards somewhere here. Didn't I? Yeah, he's here. So this PCB color, that's a yellow. Maybe I can do a board that's like butter shaped. Butterpie, it's cool. I will. I hope I don't forget it until tomorrow or until I try it. Butterfly, butterpie. Okay, Electron Ash. Ash, I think we need to talk. Yeah, okay. There is the FPGA that I got is not fast enough for HDMI, I found out, maybe with some tricks, but you can feed it from the ESP32, so you don't need an external flash or something. You can simply use the ESP32 to load it with code. I think so. You can program it at least. Cream pie. Oh. Ice 40. Yeah, I think it was an Ice 40. Okay, if you have enough pins, you can do BT656 style video to an HDMI chip. Might only do 422 chroma, but that's not... What? Ash, I need all this information. Give it to me. What? I got everything, every part that I need for an Ice 40 board here. I have all the oscillators, I have all the values that I need to set it up. I even got a dev board, I think, with the Ice 40. BT656 was the 8-bit bus often used for the most DVD players and set-top boxes and considered broadcast quality. What? With 16-bit color or what? The Verilog for BT is simple enough. What is the bit rate? So what is the frequency of that? Yeah, 27. Ooh, that was a mosquito. Yeah, no, full HD not, but 480p is good enough. That's what we want. Should be supported by every TV. Yeah, but you know, the Ice 40 720p, I think with an external HDMI chip, I can handle like VGA with the ESP32. At least I think it could be doable. Yeah, age-old problem with the lack of I/O pins. Yeah, I'm not sure. Let's... Okay. We will talk about this the next time, or the next night shift where we do FPGA design or something. USB-C video? Oh, Aaron. But you can't connect it to a TV. Oh, wait a second. There are simple converters. I got one too from USB-C to HDMI. But you need the data rate there. So just RGB component output. What? Ash, can you link to your stuff, please? You are moderator, so you can drop some links. Twitter. But I'm on Discord. Yeah, which Discord are you? Are you on mine? Or only on Sion's? We might have talked already. I don't have Discord open because it will. Yeah. Yeah, same for me. I have like ton of Discords, and my Discord I lost track. It's like 90 people are online right now on my Discord, and 424 offline. So we got over 500 people on my Discord alone. Let me search if you're the Ash. Uh-oh, I don't see you. Okay, let's talk another time. I think that's all for today. Thanks for you guys. I hope it was a nice night shift for you as well. And we got 2 running boards. Oh no, that's the old one. Yeah, 2 running boards here. And they look fine, even though we had quite some fun removing solder bridges for hours. Butter pie, okay. Yeah, Aaron, you can post it in the butter channel. You will get if you didn't get yet a butter master for that. Or who's okay. Bye bye guys. Ciao.